Assalamualaikum warahmatullahi wabarakatuh, and good day everyone. My name is Sharifah Amila binti Syed Ahmad Afandi, and today I will present my research titled Manganese Peroxidase and Protease Determination in Aspergillus flavus and Aspergillus fumigatus. Begin, let's look at the background of the study. First, this research aims to explore fungal-derived enzyme as a sustainable and cost-effective alternative. Why? Because there is a growing demand for efficient, eco-friendly enzymes, especially in the fields of wastewater treatment, biofuel production, food processing, and pulp bleaching. Next, why Aspergillus species is chosen? Because it is a well-established genus in biotechnology due to its fast growth, simple cultivation, and ability to secrete large amounts of extracellular enzymes. And in this research, the strains that are being used are Aspergillus flavus and Aspergillus fumigatus. By studying both species, we can compare the enzyme production potential of two clinically and environmentally relevant fungi. Now, let's look at the problem statement. Aspergillus flavus and Aspergillus fumigatus are common pathogenic fungi that generate enzymes with important industrial applications, including MNP and other proteases. However, little is known about MNP and proteases from Aspergillus flavus and Aspergillus fumigatus. Hence, research on these enzymes will lead to more efficient industrial applications. Then, despite existing studies, there are still limited comparative studies on Aspergillus flavus and Aspergillus fumigatus under the same experimental conditions. Next, this research is structured around two research questions. First, will Aspergillus flavus and Aspergillus fumigatus produce MNP and proteases under controlled conditions? Second, what are the activity levels of MNP and proteases in Aspergillus flavus and Aspergillus fumigatus? There are two main objectives of this research. First, to determine the production of MNP and protease in Aspergillus flavus and Aspergillus fumigatus under controlled conditions. And second is to evaluate the activity of MNP and proteases of Aspergillus flavus and Aspergillus fumigatus. The methodology of this study can be summarized into four main steps: media preparation, spore suspension preparation, fungal cultivation under controlled conditions, and enzyme extraction with activity screening. First, microscopic and microscopic observations were made to identify the morphology and characteristics of Aspergillus flavus and Aspergillus fumigatus. The macroscopic observation of Aspergillus flavus was performed on the 7th day of incubation, and the isolates were yellow-green with a dense powdery texture. The fungal isolate surfaces appear flat with a dense mycelial mat, as well as filamentous margins and noticeable coloration on the plate's reverse side. Then, macroscopic observation of Aspergillus flavus was performed on the 3rd day of incubation at 100 times magnification using a light microscope. And from the observation, we can see various structures such as vesicles, phyalites, conidia, and conidiophores. The vesicle appears globose and is coated with biserrate phyalites. The conidiophore is thick, whereas the conidia are round. As for Aspergillus fumigatus, the macroscopic observation was also performed on the 7th day of incubation. The observation reveals a blue-green or dark turquoise coloration with a velvety to powdery texture. The colony margin is slightly filamentous or regular, and the reverse side has subtle yellow pigmentation. And then, microscopic observation of Aspergillus fumigatus was performed on the 3rd day of incubation at 100 times magnification using a light microscope. The observation encompasses features such as conidiophores, vesicles, phyalites, and conidia. The conidiophore is relatively thin and smooth, and the phyalites are organized uniseriately, covering only the top half of the vesicle. Next, the production of MNP was qualitatively assessed using CDA with phenol rate as a pH indicator. Initially, the medium appears red due to its neutral to slightly alkaline pH. So when MNP is secreted, it catalyzes the oxidation of Mn2+ to Mn3+ in the presence of H2O2. The Mn3+ then oxidizes phenolic compounds in the phenol rate, producing organic acids that lower the pH, which cause the phenol rate to shift from red to yellow, indicating enzyme activity. Across all CDA plates, the positive controls consistently showed pronounced yellow zones, confirming effective enzyme-mediated dye transformation. The test fungal sample inoculated in the bottom part also exhibited significant degrees of color changes, and most notably in plates A, C, D, and E, while the negative controls remain unchanged in plates A, D, E, and F. Next, protease activity was evaluated using SMA plates, with casein serving as the substrate. Upon hydrolysis by fungal proteases, the medium clears around the colony due to the breakdown of casein in the agar. Of the two strains studied, both exhibited enzymatic activity in the qualitative assay, as confirmed by the formation of a clear zone. As shown in the observation, the positive controls demonstrated distinct hollows, while the negative controls showed slight to no clearing in most plates. The fungal samples produced visible hollows in the bottom parts of the SMA, confirming extracellular protease production. Then, the absorbance was recorded every minute for 4 minutes with a 0.1 absorbance unit increase per minute equivalent to 1 unit per mil MNP activity. A steeper increase indicated higher MNP activity. MNP activity was directly proportional to absorbance, with higher values indicating greater enzyme activity. From the table, we can see that at 0 minutes, all samples showed baseline readings, with the Pleurotus pulmonaris as the positive control having the highest absorbance, followed by Aspergillus fumigatus and Aspergillus flavus. Over time, the absorbance increased for all samples, reflecting progressive MNP activity. Aspergillus flavus showed a small but consistent rise by minute 2 and remaining steady. Aspergillus fumigatus followed a similar trend but reached a slightly higher final value, indicating moderately higher MNP activity. Then, the positive control showed a more pronounced and steady increase, confirming its strong MNP producing capacity. From the graph, the slope values indicate the rate of MNP activity per minute. Pleurotus pulmonaris showed the highest enzyme activity with the steepest slope and the strongest correlation, confirming consistent MNP production over time. Aspergillus fumigatus demonstrated moderate activity with a slope of 0.0184 and NR squared of 0.639, indicating a steady but more variable trend. Aspergillus flavus had the lowest slope and R squared, suggesting minimal activity and weaker linear consistency. Next, the spectrophotometric assay for protease activity is based on casein hydrolysis and the colorimetric detection of tyrosine. The table shows absorbance values at 660 nanometer for Aspergillus flavus, Aspergillus fumigatus, and Aspergillus niger, all at a 0.5 dilution. Higher absorbance indicates greater casein degradation and higher protease activity. Among the 3 samples, the positive control, which is Aspergillus niger, showed the highest protease activity, though the large standard deviation indicates notable variability. Aspergillus flavus exhibited moderate activity with some variation across the replicates, whereas Aspergillus fumigatus had the lowest activity but with minimal variation, suggesting consistent yet low enzyme production. Next, a standard curve was generated using known tyrosine concentrations from 0 to 100 microgram per mil, with absorbance measured at a specific wavelength. Absorbance increased with concentration, showing a linear trend consistent with the Beer-Lambert's law. The blank had an absorbance of 0.000, confirming no background interference, while slight variation was noted between 20 and 40 microgram per mil. The overall relationship remained linear. This standard curve was used to determine tyrosine concentrations in enzyme-treated samples by interpolating their absorbance values. The curve served as a reference to convert absorbance values into microgram per mil of tyrosine release, enabling the estimation of protease activity in the tested fungal strains. Overall, Aspergillus niger was confirmed as the most efficient protease producer, validating its role as a positive control, while Aspergillus flavus showed moderate potential, and Aspergillus fumigatus demonstrated limited activity. In this research, MNP activities for Aspergillus flavus, Aspergillus fumigatus, and Pleurotus pulmonaris were recorded as shown in the table respectively. These values far exceed those reported by Benavides, where P. chrysosporium, P. osteratus, and C. duceni showed maximum MNP activities of 176, 200, and 300 unit per mil. Notably, Aspergillus niger, as the positive control, produced a significantly higher protease yield than any of the values reported by Usman, while the activity of Aspergillus flavus was nearly identical to their wet bran fermentation result. This suggests that submerged fermentation, under the conditions applied in this research, may be equally or even more effective than solid-state fermentation for certain fungal strains, particularly for Aspergillus niger. In conclusion, Aspergillus flavus and Aspergillus fumigatus demonstrated the ability to produce manganese peroxidase and protease enzymes. Aspergillus fumigatus exhibited higher MNP activity compared to Aspergillus flavus, while Aspergillus flavus showed higher protease activity. The positive controls consistently showed the highest enzyme activity, validating the assay and highlighting the industrial relevance of the selected methods. In the future, we can use multiple fungal strains to better understand species variability and genetic influence on enzyme production. Or we can also explore a broader range of culture conditions, investigate enzyme stability and purification to assess potential for industrial applications, and also might consider performing molecular studies to uncover the regulatory mechanisms of MNP and protease production. So that's all from me. Thank you.